Pluto has a way of staying with you. For a world we once dismissed, demoted, and largely forgot about, it manages to keep pulling people back in. And honestly, that makes complete sense. The more you learn about it, the more questions start stacking up. You might have watched a video, read an article, or even just seen that famous heart-shaped plane in a photograph and thought, wait, how does that even exist? What is actually happening out there? Well, today, we are going to dig into some of the most fascinating questions about Pluto that people keep asking. Some of these have answers that feel almost too strange to be real. Others say as much about how science works as they do about Pluto itself. And a few of them, I think, will leave you with a genuine sense of wonder about just how remarkable this small, distant world actually is. This is probably the single most striking thing people notice when they first see Pluto up close. Right there on its surface is a massive, pale, roughly heart-shaped region. It is enormous, over 2,000 kilometers across, which would stretch from one side of Western Europe to well past its eastern edge. And it is impossibly smooth and bright, compared to the rugged dark terrain surrounding it. This feature is called Tombor Regio, named after Clyde Tombor, the man who discovered Pluto back in 1930. But the western half of it, the main lobe of the heart, is what scientists are most fascinated by. That portion is officially named Sputnik Planitia, and it sits in a basin thought to be the result of an ancient and catastrophic impact event. Something enormous slammed into Pluto long ago, gouging out a depression that has since been slowly filling and reshaping itself over billions of years. But what filled it? Nitrogen ice, and not just a thin coat of it. Scientists believe Sputnik Planitia holds a sheet of frozen nitrogen that is several kilometers deep in places. Because it sits in a low-lying basin, nitrogen naturally migrates toward this region as it cycles across the surface seasonally, pooling here the way water fills the lowest point of a landscape. Over time, the result is this vast, pale expanse that dominates one whole face of the planet. If you look closely at images of Sputnik Planitia, you can see that the surface is not completely uniform. It is divided into irregular polygon shapes, hundreds of kilometers across, separated by shallow troughs. These are the tops of enormous convection cells, columns of slightly warmer nitrogen ice slowly rising from below, spreading out at the surface, cooling and sinking again. The process is similar in principle to what happens in a pot of thick liquid beginning to heat, except in this case, each single convection cycle takes somewhere in the region of 500,000 years to complete. Pluto is patient in ways that are difficult to fully absorb. Here is where it gets even more remarkable. Because Sputnik Planitia is so massive and holds so much dense ice, it actually influences Pluto's rotation. The concentration of mass in this basin is significant enough that models suggest it caused Pluto to gradually reorient itself over geological time, tilting and shifting until Sputnik Planitia came to rest in the position most gravitationally stable relative to Charon, Pluto's largest moon. The two bodies are tidally locked to each other, and the heart now faces permanently away from Charon on the opposite hemisphere. In other words, an ancient collision created a basin. Nitrogen ice filled it over billions of years, and the accumulated weight of that ice physically rotated the entire world into a new orientation. The heart, in a very real sense, may have steered the planet. Most people picture Pluto as a frozen, airless rock floating in permanent darkness. And while it is certainly frozen, the airless part is not quite accurate. Pluto does have an atmosphere. A thin one, absolutely, but a genuine one. It is composed primarily of nitrogen, with small amounts of methane and carbon monoxide mixed in. When New Horizons flew past in 2015, scientists got their clearest look yet at this atmospheric layer. And what they found was surprising in several ways. The atmosphere extends far higher above the surface than expected. We are talking about a haze layer that reaches thousands of kilometers above the ground, which, for a body as small as Pluto, is proportionally enormous. Within that haze, there are distinct layers, produced when ultraviolet radiation from the sun breaks apart methane molecules. Those fragments then recombine into more complex organic compounds called tholins, which scatter incoming light and create a soft, layered glow around the planet's edge. That scattering is what gave Pluto's limb a striking blue tint in some of the New Horizons backlit images, taken as the spacecraft looked back toward the Sun after its closest approach. It is one of the most unexpectedly beautiful things in the entire archive from that mission. A deep, faint blue ring of haze around a world that most people assumed would look completely dead and featureless. Those images genuinely changed how a lot of scientists thought about what small, cold, distant worlds could look like. But here is where the strangeness really deepens. Pluto's atmosphere is not stable over time. Because Pluto travels along an extremely elongated orbit, its distance from the Sun changes dramatically across its 248-year-long year. When it is closest to the Sun, surface temperatures rise just enough for nitrogen and methane ices to sublimate, bypassing the liquid phase entirely and converting directly from solid to gas. That process inflates the atmosphere, making it thicker and more extended. As Pluto moves away and temperatures drop again, the process reverses. The atmosphere gradually snows back down onto the surface, molecule by molecule, eventually freezing out almost entirely. We are currently in a phase where Pluto is moving away from the Sun, following its most recent closest approach back in 1989. Scientists have been monitoring how the atmosphere is responding as temperatures slowly fall, and the data suggests the process of atmospheric collapse may already be underway. There is a real possibility that over the coming decades, the nitrogen haze layers will thin dramatically, and the atmosphere will shrink to a fraction of what New Horizons observed. Pluto breathes on a timescale of centuries, and right now, it may be slowly exhaling for the last time before a very long winter. Now, this is the question that reliably keeps comment sections running hot. People feel strongly about this, and I do understand why. It feels personal. There is something that sits uncomfortably with a lot of people about a world that held planetary status for 76 years being quietly stripped of that title at a meeting most people never heard of. So, could it come back? Scientifically, the answer is not impossible. The definition of planet, adopted in 2006 by the International Astronomical Union, is not a law of physics. It is a human classification decision, and classification decisions can always be revisited. The debate has never fully gone away. That 2006 vote was famously attended by only a small fraction of the IAU's total membership, a few hundred astronomers out of thousands, and the decision was far from unanimous. Some researchers have argued the definition itself contains technical inconsistencies. For example, the requirement that a planet must have cleared the neighborhood around its orbit has no clearly defined numerical threshold. Depending on how strictly you apply it, even Earth and Jupiter could be questioned, given the asteroid populations that share their orbital zones. A number of planetary scientists prefer what is sometimes called the geophysical definition. Essentially, any body massive enough for its own self-gravity to pull it into a roughly spherical shape. Under that standard, Pluto qualifies without difficulty. So do several other round objects in the outer solar system, including Eris, Makemake, and Haumea. But this is exactly where the complexity enters. If you adopt a broader definition, you are not simply restoring Pluto's status, you are opening the door to a much larger list. Astronomers currently estimate there may be dozens, possibly hundreds, of roughly spherical bodies in the Kuiper Belt and beyond, many of which we have not yet fully characterized. The solar system could, under some definitions, contain 50 or more planets. At some point, a category that includes everything stops being a useful scientific tool. The argument for keeping the current classification is not really about diminishing Pluto. It is about recognizing that the outer solar system is genuinely, fundamentally different from the inner solar system, and that the population of Kuiper Belt objects represents its own distinct class of world. Giving that class its own category, dwarf planets, is, in that sense, more honest about what the solar system actually looks like than forcing everything into a single bucket. That said, science moves. Future surveys of the outer solar system, or perhaps the discovery of a genuinely massive object far beyond the known Kuiper Belt, could force another rethink of how we draw these lines. Pluto's story may not be completely finished. This is the question I personally find hardest to stop thinking about. Setting aside all the practical obstacles, the travel time alone using current propulsion technology would be somewhere around 10 years. Just try to imagine it for a moment. You are standing on Pluto. What do you experience? The first thing you would notice is the weight, or rather, the near total absence of it. Pluto's surface gravity is roughly 6% of Earth's. If you weigh 80 kilograms here, you would weigh less than 5 kilograms there. Every step would launch you into a slow, floating arc. Moving around would feel somewhere between the moon and a dream. You would need to be deliberate about every movement, because momentum behaves very differently when gravity is this weak. Running, jumping, even turning quickly could send you tumbling. The next thing you would notice is the silence. Not just quiet, a total, complete, absolute silence in every direction. The atmosphere is so extraordinarily thin that sound effectively does not travel through it in any meaningful way. You could be standing next to a collapsing cliff of nitrogen ice and hear absolutely nothing through the environment around you. That particular kind of silence, the silence of a world with almost no air, is something human beings have almost no frame of reference for. The light would surprise you. Most people assume Pluto would be pitch dark, but it is not. The sun from Pluto's average distance looks like an intensely bright star, far brighter than any star in our night sky, but still around 1,600 times dimmer than what we experience on Earth. Your eyes would adapt. Scientists describe it as roughly comparable to the light level during heavy overcast on a winter afternoon. Dim, shadowless, and flat, but absolutely not dark. You could see the terrain around you clearly. You could read if you had something to read. And the terrain would be extraordinary. There would be mountains in the distance, water ice mountains, some rising more than 3 kilometers above the plains, their flanks dark and rugged against the pale flatness of the surrounding landscape. Underfoot, the ground might be nitrogen ice, slightly giving and granular in texture, pale and reflective. In some areas it would be methane ice, which tends to darker reddish-brown tones, or carbon monoxide ice, which can appear almost translucent. Looking toward the horizon, you would see the vast, bright expanse of Sputnik Planitia spreading away from you, catching what little sunlight reaches this far out and reflecting it back with unusual brightness. The surface of that plane is not featureless. It has those enormous, slowly churning polygon shapes, visible as subtle ridges, like the top of a creme brulee scaled up to the size of a continent. Above you, Charon would dominate the sky in a way that would feel deeply unfamiliar. It is so large relative to Pluto, and so close that it appears roughly 7 times wider than the full moon does from Earth. A massive, grey, cratered world just hanging there, completely still, never rising, never setting, simply fixed in place above the same hemisphere forever. The sky around it, if the haze were clear enough, would show a deep, dark blue, not from reflected ocean light as on Earth, but from that same thin, scattering haze that made the limb glow in New Horizons images. Standing there, in that thin blue twilight, on a world smaller than our moon, further from the sun than most people can meaningfully picture, surrounded by absolute silence and impossible stillness, it would be one of the most profoundly alien and genuinely humbling experiences it is possible to imagine. Pluto has this remarkable quality of refusing to be simple. Every answer it gives you seems to arrive with 2 more questions attached. The heart that may have physically rotated a world, the atmosphere that breathes in and out across centuries, the classification debate that is still quietly, not fully settled, the surface that, if you were standing on it, would feel both impossibly foreign and unexpectedly beautiful. And we saw all of this, or at least the first glimpse of it, from a spacecraft the size of a grand piano, flying past in a matter of hours, billions of kilometers from home, with no chance of turning back. There is something genuinely moving about that. We sent a small machine out into the dark, and it showed us a world we had never truly seen before. And the more it revealed, the more it became clear how much there is still left to understand, how much the outer solar system is hiding, patient and cold, waiting for the next visitor to pass through. If Pluto has left you with more questions than you started with, leave them below. That is usually a sign that something real has been learned. The universe rarely runs out of things to teach us, and Pluto, tiny, reclassified, magnificent Pluto, seems to have no shortage of surprises remaining.